Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Any question from the homework? I give you some questions. Any problem? Okay, semua. Okay. All right. Good. So I hope you did a few questions on the second partial derivative test. All right. Today, what we are going to do, I'm going to finish up this chapter 14. We will do the application, which is 14.4. And then we move on to the new topic, okay, to a new topic that is on integration. And again, I would like to remind that our test would be on Sunday, okay, this Sunday. So for those people who, there will be a few, or one or two, who couldn't be, who didn't bother about my announcement. And suddenly, last minute, they will ask. So our midterm will be on Sunday, which is on the 9th of May, 21. And the time is 10:30 p.m. After everything settled down, you can eat, you can drink, all right? So we do the test. Hopefully this is a good time. And I hope nobody will make excuse, okay, for not being able to take the test. Unless, of course, there is some emergency reason. But, under normal circumstance, don't get sick, okay? Don't get fever during that day. Some people, from my experience, during the test day, masa itulah lah demam.
Oh God, we're trapped inside. Still out court. He's still out court.
Wah, siapa? Gaduh. Aku nak ambil. Okay. Lagi tak dia. Is he from somebody from our class? The sound. Okay, so that is the test. All right. And on Wednesday, hopefully I can, if you have anything. So Wednesday, this coming Wednesday, if you have any question or any comment, from the topic, so we can spend some time to discuss any of the things of your concern that you may have for the topics. So let's look at application. Now you go to 14.4. The application I want to look at is example number 4. So please read example number 4, that is on the maximum profit. Now the applications, as you can see, they are common application, which we already saw. Nothing different. The only difference would be the method. Here you have a function of two goods or two variables. Oh, no, a function of two independent variables. So therefore, if you're looking at production or you're looking at profit, okay, these functions will made up of two independent variables. It can be two goods or two products, or it can be two inputs. Okay, so that is the only difference. Okay, now if you look at example number 4, you have this company producing two types of lamps. So you see here 20-inch lamp, 31-inch lamp, and we assign, all right, first that you need to do is, of course, you need to assign X and Y to the different products or different variables. So here we can say X is the 21-inch lamp. Yeah, 21-inch lamp in unit.
Your screen.
Apa dia? Yes.
You haven't shared your screen.
Oh, I have not. Okay, sorry. I thought I had. So if you look at the example number 4, okay, when I talk about the test, did I share screen? Of course not. So I just go back from the beginning. The test on the 9th of May, okay, 2:30 p.m. 10:30 after Taraweh. Good time, all right? Okay, and then Wednesday, any discussion, you can spend some time. Otherwise, we will continue with the new topic. So what I do today, which I haven't write down here, what I do today, I'm going to finish up with the applications, chapter number 14. Then we finish 14, all right? And then we go to a new topic, integration, chapter number 12. So that is our plan for today. All right. So go back to the example. You have two goods. So you let X be the 21-inch lamp in units, and then Y will be the 30-inch lamp also in the units, in the number of, that's the quantity. And then the profit is the dollars, is in terms of dollars. Okay, so here you got the dollars. So if you look at the units is not in one, it's in thousands. Okay, so the units of X and Y are all in thousands. And then the P will be the profit, also in dollars and in thousands of dollars. $1,000 and 1,000 means if the X is equal to 2, it means 2,000. Okay, because 2,000, it's thousands, everything is in thousands. So that is the units for every variable. So you are given the profit, you are given the demand function, and then you are given the cost. So you want to find, okay, what is the X and Y to sell in order to maximize profit. To maximize profit. And what is the maximum profit? So question to make what you need to find X and Y that maximize profit, and then what is the maximum profit? So what we are going to find is simply the critical point, okay? And then that critical point should be a maximum. So that is what we need to do. So you apply the second derivative test. So here, the second partial derivative test. So first, you need to find the critical point. Secondly, you use that D, okay? That D, you have to compute and then determine whether it is a maximum or minimum. So go back to the problem. You have profit equal to revenue minus cost, and cost is already been given, so no problem, you don't need to find. Now you need to find revenue, because revenue is not given directly. Now, what is revenue? If you recall revenue from the previous chapter, what is revenue? How do you get revenue? If you have only one good X, how do you get revenue?
Price time quantity.
The price or quantity. So everything will begin from there. Okay, you have, if you recall, if there is one good, then the revenue will be P times X. That is the revenue from the good X. Now, if you have two goods, okay, X and Y, then the revenue would be what? Would be the revenue from what? Revenue from the sale of X and the sale of Y. So if you are selling two goods, all right, let's say you sell burgers and also you sell Coke, then what is your revenue? If you just sell burger, then your revenue is from the sale of the burger. Now you add another good, Coke. So what is your revenue now? How do you get revenue now? How do you get your revenue? You simply add, okay? You simply add the revenue from the sale of the two goods. So you get the revenue from the X, which is your burger, plus the revenue from Y, which is Coke. So for any goods, two goods, X and Y, is revenue from X, revenue from Y. And that will be equal to what? That will be equal to just PX times X, revenue from X, plus PY times Y, which is revenue from Y. So PX and Y, PX and PY are the prices. Okay, all right. So that is getting the what do you call it? Getting the revenue. No, the revenue and then the profit. So that's how you get the profit for the case where you have two goods. So here, all right, you have PX, which is the price of 21-inch lamp, and then PY, which is the price of the 30-inch lamp. So therefore, that will be equal to what? That will be equal to 50 minus X multiplied by X plus 60 minus 2Y multiplied by Y. So, internet saya tak stable. I don't know, Petang ni tak stable. And that will be equal to 50X minus X squared. $50X minus X squared plus 60Y minus 2Y squared. So that is our revenue. So the profit will be equal to revenue minus cost. Then you put in the specific revenue which we already obtained. So that will be 50X minus X squared plus 60Y minus 2Y squared minus the cost, which is 2XY. Okay, so that is our profit. And of course, I don't think we can simplify anything. So that will be our profit. So now, number one, what we do? You find critical points. Now, what is the condition for critical point? 4 points. Px equals 0, Py equals 0. Okay, so first you find Px. What is Px? So 50 minus 2x minus 2y. Okay, so first term is 50x and then x squared and then 2xy. So Py, that is equal to what? You have the x here, oh no, I'm sorry, y, and then, so there will be 60 minus 4y minus 2x. And then for critical point, set that to 0. So what do we get? We get a system of two equations. 2x minus 2y equals 0. That is number 1. And then I have 60 minus 4y minus 2x. That is equal to 0. That will be number 2. Okay. All right. So I want you to solve the system. Okay. So homework. Do it at home. Okay, do it after the class. Find the solution. Of course, we know the solution. If you look at the example, the solution is already given. Y equal to 5 and then x equal to 20. We know that, okay? But I want you to show the work, okay? How you do about getting the equilibrium point. So do that as a homework. So what we get? solving the system, I got x equal to 20, y equal to 5. So that is our critical values of x and y. Okay, and of course, from there you can find the profit. But we don't need that now, okay? We need later. We just need x and y in order for you to find the maximum, the minimum point. Now, after you have the critical point, what do we do? Number two, you have to show it as a maximum, because sometimes it can be minimum. So therefore, we use that d. What is the d? Now, if you recall, d is fxx, fyy, minus fxy squared. So in case now you have the profit, so it will be pxx multiplied by pyy minus pxy squared. So make sure, we use the right notation for the right equation. So we need to find pxx, which is equal to what? Equal to -2. And then you need to find pyy, that is equal to -4. And then pxy, that is equal to -2. Which is also equal to, if you do it that way, pyx equal to -2. So you see here they are equal, so we are right. So those are the second partials. Now substitute into the d. So the d would become equal to what? Would become -2 times -4 minus -2 to the power of 2, which is equal to 2 times 8, 8 minus 4, that will be equal to 4, and that is bigger than 0. Okay, all right. So I think what we do, we evaluate. So I think we don't put the x be bigger than 0 yet. So that be bigger than 0. So what we do, we make another step at the critical point. Okay. So at the critical point, x equal to 20, y equal to 5. Everything is a constant, so remain everything the same. D is equal to 4. Okay, because it's a constant, so everything will be the same. And that d is bigger than 0. So d bigger than 0, you may have a maximum or you may have a minimum. All right, if d is negative, you have a inflection point, we stop there. If d is equal to 0, the test doesn't work, so we stop there too. So but d is bigger than 0. So we have to look at the second partial. So d bigger than 0, we look at pxx. And pxx is equal to -2 and it's less than 0. Look at pyy, which is equal to -4, and that is less than 0. So therefore what? Therefore, profit has a maximum or minimum? Has a maximum, negative, okay? The partials negative. So has a maximum at x equal to 20, y equal to 5. And then you find the profit, right, at that point, at 25. So you look at the book, they find it for you already. We got 650. No, we don't, they just got it. So what you can do, how do you get the 650? Substitute back into the profit. Okay, so the 20 and 5, you substitute into P. So make sure you substitute into the P, you get 650. Okay, so that is our solution. Okay, any question? So what we do now is describe that point. So that is the maximum point, correct? That is the critical point, and that critical point is the maximum. So what you do here, profit has a maximum at x equal to 20, y equal to 5, and then you find the maximum profit at 20 and 5, you got 650. So therefore, we say that profit is maximum at, okay, that means to maximize the profit. I think I will say the sentence, the English sentence. So we say that to maximize profit, how much do you have to sell? I sell 20x is equal to 20. Now units are 1,000. So 20,000 units of the 21-inch lamp and 5,000 the 30-inch lamp. And then you say the value of the maximum profit. The maximum profit is equal to what? The maximum profit is equal to $650,000. Okay, so that's it. All right. So that is our conclusion. The conclusion is to describe the critical point, and that critical point is maximum. So you have to describe, okay? Describe the maximum point. Okay. All right. So in that case, you got the x equal to 20, y equal to 5, and then you describe it in terms of the what? In terms of the unit. Okay, and then describe it correctly. Okay, all right, good. Now I give you some questions on 14.4. Let you to do question number 19, the application, 22, 23, 24, 25, and then 29. Okay. Now today, I give an in-class homework. I will give you also, I give my morning class the in-class homework. The question that I want you to do is question number 25. So question number 25, which is maximizing profit, similar to the example. Okay, so I want you to do this one now. Okay, so you got an in-class homework. You do it now, and then we discuss. Everybody will get 5 marks. So that will be only 5 marks, because I'm going to discuss it. And then you submit to me in classroom after the class. Okay, I will put the assignment in classroom. All right, so do it in a standard paper, put your name, metric number, and your section number also. All right, so do it now. I give you, tak kira lah berapa minit, 15 minutes. So now I give you first 5 minutes. Okay, 5 minutes to develop the problem, and then I will discuss, and then we proceed. Okay, all right. So do it now. I put the question, okay, in the classroom. So you submit through the classroom. Okay, you got the profit function?
Yes, sir.
Okay, now if you look at the profit function, no, the revenue, the demand function. The demand function is given not as in our example. The demand function is given as x function of p. And then our problem, we need to find the quantities. Okay, we don't need to find the price. Of course, the price you can find later on, but you don't. The second derivative test, we need to find what? You need to find x and y. So you don't put the demand function in terms of the price. If you do that, then everything you will have, the profit will be depending on the price and the x's, or the x and y, which is not right. So what you need to do, what do we need to do? You need to rewrite the demand function. Okay, so the demand function you need to write. You are given here x function of p and px lah, and then y is also a function of p, which is py. So what you need, you have to rewrite px in terms of x, and then py also in terms of y. Okay, so that means if you look at the x, so you got px equal to what? Equal to x minus 70. No, I'm sorry, 70 minus x. So px is equal to 70 minus x. And then you do that for py. Now, did you do that change? Yes or no? For those people who did not do the change, do the correction now. Okay, you have to write for the demand function, which is the price, px in terms of x, py in terms of y, then only you put into the revenue function. So if you got it wrong, don't erase, don't do anything. You just do the correction, okay, on the side or below it. Okay, anybody got it wrong? Can you raise up your voice? Anybody got it wrong? Anybody put in the original function?
Me, sir.
Okay, so make sure the profit will be of the same variable. Okay, we cannot mix p and x and y. Okay, otherwise, if you do that, that means you cannot take the derivative, because you have the price, you have the quantities. So first thing that we need to do, rewrite the demand function. Okay, good. Okay, now proceed. Oh, I already put the assignment number 2 in the classroom. Hello. So after you do this, all right, you have the revenue equal to what? Equal to PXX plus PYY. And that will be equal to 70 minus X multiplied by X plus PY, which is equal to 80 minus Y plus 80 minus Y times Y. So that is our revenue. Therefore, the profit will be equal to, you put in this thing here, minus the cost, which is XY. And then find critical point. Okay, everybody up here? Okay, so next, okay, find the critical point. Mana pergi kan? Okay, so what you will get, sorry. Okay, what you will get will be equal to what? Will be the profit. Okay, show the work. Okay, I just give you the form. Will be 70x minus x squared plus 80y minus y minus xy. Okay, is that right? You got it?
Yes.
Okay, good. Now, number 1, you find the critical point. Okay, you find the critical point. I want you to find the critical point and then set the condition for critical point, Px equal to 0, Py equal to 0. Okay, but first find the first partial, Px and Py. So you find Px, find Py, and then set that to 0. So I just write down now, okay, the system. So after you do that, then what you will get will be the two, you set the Px and Py equal to 0. So what you get will be 70 minus 2x minus 2y. Not 2y, there is only one y. You have xy, okay? Xy, so minus y, set that to 0. Call it number 1. Everybody got this? Okay, if you got it wrong, make the correction. 80 minus 2y minus x equal 0. Call it number 2. So this is the system. So now I want you to find the solution. Very simple, okay? Because you have x and y, and then you can substitute. So you write x in terms of y, or y in terms of x from 1 or 2, and then substitute into the other equation. So find x, y. Okay, do it now. Okay, you got it. I'm not going to do this, okay, because by now, this is on the first topic, we should be able to do that. So I just give you some guidelines. So you can start with number 1. So from number 1, you will get y equals what? 70 minus 2x. And then you substitute into number 2. Okay, everybody got that? Everybody finished this part? Okay, anybody who get the solution, what is x equal to? And what is y?
X 20, Y 30.
Okay, x 20, y 30. Okay, all right. Satu benda lagi. One more thing, which I did not do from the beginning, because you need to look at the units, okay? Look at the units of the x and y. So go back to the question. If you haven't done so yet, we will do it now. So if you look at the question, what are the two goods? What are the x and y? So here should be, this one should be from at the beginning, okay? I hope you did that, because I didn't, because I just go to the demand function. So what is the product? The product is to the other two brands. So you call X the brand 1, okay, in units. And unit, if you look at the question, it's not just unit, it is thousands unit. So you put in the thousands. Okay, thousands units. And then Y is the quantity of brand number 2, also thousands units. And then the profit is in dollars, also thousands. So those are the units, okay? The units for the profit and also the quantities. Okay, all right. So now you do the second part. Now for the second part, you know what is the D, okay? The D in which you need to determine for maximum or minimum. D is equal to what? D is equal to fxx, fyy minus fxy squared. So in terms of P, so that will become pxx, pyy minus pxy squared. So now you do the second part, get the second partial.